So I changed the title of my talk. It's all right, I'm moving quickly here. Catch up. Today, the XKCD came out a couple of hours ago, and it was very appropriate to my talk. The guy says my motto is move fast and break things. And he says jobs I've been fired from. I took this as a sign that this is the talk I should give today. So, move fast and break nothing. We've probably seen this quote a couple of times. Mark Zuckerberg has said this so many times over the course of Facebook that there were a 2-month time period in 2010 where this is all he said. You would try and ask him, can I get some help on this? And he'd just be like, move fast and break things. Very frustrating if you're at Facebook, I would imagine. This is what they said a lot up until this year when they decided to switch it to move fast and fix things, which I guess they wanted to fix things. That's cool. And then they decided to also say move fast with stable infra, which is not as sexy and sleek. They moved too fast to put the end of infrastructure on it, I guess. Another Facebook engineer is like, no, I like move fast and be bold better, which has the benefit of actually saying nothing, which is impressive. My favorite is definitely Drop the It's Cleaner by Justin Timberlake. So obviously Facebook's had a bunch of different philosophies around this, and this is philosophy. Moving quickly and safely is good philosophy. And Facebook got a bunch of crap for going back and saying, oh, now we don't want to break things. Now we want to be a little bit more cautious. And I think that's crap. I think it's awesome for a company to evolve over time. And that's a good thing. I don't want to work at a company that's something like, nah, we did this 10 years ago, and now therefore our company is the exact same as we used to be. It's good to change. So when they've been saying this sort of stuff, it's been really interesting to me to hear Facebook talk about this stuff. But I don't work at Facebook, so I wanted to think about, well, what does it mean in practice? I know what this means externally. It probably means less breaking things for their API, for example. But obviously this probably means a lot internally too. How do they change their organization to support this new vision or whatever you want to call it? So that's what I want to talk about today in this talk. I am Zach Holman. I'm Holman on Twitter, Holman on GitHub. This is me with Nala, my favorite office dog. She's my favorite office dog because she knows how to use the elevators now, and she just pops up on different floors, which I love. And I do work at GitHub. I've worked at GitHub for 4.5 years, and I've seen it grow from 9 employees to 230 some. So a lot of what this talk is about, not necessarily about GitHub, but we've seen a lot of similar things that I'll talk about, and I think it's really interesting. As you move from going, I want to go really fast, I want to break a lot of stuff, to can I still go really fast, but can I still do some really interesting, safe things as well? Right when I was sort of asked to give this talk, I was talking to my friend on IM, and we're talking about some other stuff, and all of a sudden she asked me, do you know why kittens, puppies are so cute? And I was like, no, why? Why is that? And she said, it's so we don't fucking eat them. I was like, I guess that's true. I mean, I don't look at a kitten, I'm like, I'm just going to eat that. No, I just want to squeeze them to death and, pet them and stuff. And for some reason, I started thinking about this in the context of this talk. My brain's really strange like that, too. Kittens don't wear the sign that says, please don't eat me. By nature of their cuteness, you don't eat them if you buy into that. And I kind of extrapolated that into this. It got me thinking about, can you build an environment where success is a byproduct? So you're not necessarily going around saying, don't break stuff, because nobody really likes that dictatorial environment at work, but can you build an environment where success is that byproduct, where you feel like you're building good code just as a result of an easy process around that? So in this talk, I want to talk about 3 areas. Code is the first one, because I think you have to get into the actual nitty-gritty of code to try and figure out better ways to not break the code. I'll also talk about process a little bit, and then finally communicating how you actually discuss things in your company, I think plays a big part in whether or not you break things. First part, code. And first I want to talk about moving fast. Like, why do we say moving fast is a good thing? I think it's just you make better product for a lot of different reasons. The first one is just you get to see what works and what doesn't work. I would rather get 80% of the way next week than spend 2 years getting 100% of the way, and it waits that long for my users to actually see the results. You get to see what works in the marketplace and then change as you can. People, you tend to say that, but I think momentum is a really big part too. There's something about being in a company that is just either going really fast-paced and doing really cool product and features, and you're excited to work there, and then there's another side of working at a company where everything's very sluggish, where you have to go every single step of the way to try and get something out the door. And I think if you're going as fast as you can, there's a lot of momentum, and shipping begets shipping. So moving fast is good. The breaking things is the really interesting part. And yeah, this is my coworker's iPhone 6 on launch day. It had a crack in it. It wasn't mine, luckily. Breaking thing is interesting because usually what you say is, oh, I'm just going to fix it later. And I think that's totally fine in a lot of various use cases. And the question is, like, when is it okay to break something? When isn't it okay to break something? Because there are some things that you can't break. And move fast and break things don't tend to think about this stuff as much. One is billing. I can't just automatically charge you $1 million and say, oops, I'm moving really quickly, and vice versa. I don't want to suddenly push out a change and then none of you guys are paying for GitHub anymore. That would be a bummer for me. So billing is something that you have to move deliberately. Permissions is something else entirely. I'll get into that next. Upgrading, we just had a gnarly upgrade into Rails 3 finally, like 6 years later. And it took us 5 years until finally we just decided to revamp it all and did it all in 2 months. But that's something that you have to kind of attack in a very certain way to do it. You can't just go willy-nilly and upgrade software, because software always breaks. And then data migrations. In a lot of cases, if you're doing a really big data migration, there's no easy way back. You can't just roll back data. So you have to be a little bit careful in that route too. There's a bunch of different ways, there's a bunch of different use cases where you have to think about moving quickly. So the question is naturally, how do you move fast in really dicey code? In the last 2 years, we redid all of GitHub's permissions code, which is scary enough for me to put hella in my talk ever. I've never said hella, and I'm going to say it's really hella scary. Because that's one of the biggest things for GitHub is that your public repository or your private repository should stay private. If we say 0.01% errors, that's completely unacceptable. You can't just say, oh, I accidentally pushed something and now your code is public. Bummer. That's something where 0 errors is absolutely mandatory. And I think every sort of business has this type of use case in some aspect of their business. So the question is, how do we ship this fast and safe? Tests are great. This is not a big controversy anymore. Like, no one gets up on stage and say, you should write tests, because it's pretty obvious at this point. So tests are awesome and they're helpful. Obviously, the more tests you can do, that's great. But the problem happens when production can differ from what your tests expect. Even if you write really, really great tests, particularly if you have a very kind of mature application or it's been in the wild for a while, production can just differ from what your tests expect and then also what you even expect. So when we sat down and tried to figure out, we wanted to redo permissions because we figured out we could just do it a whole bunch faster if we just restructure our database a lot. And we did like the whole chart where we said, like, all right, users can have this permission on this repository, organizations have this permission, team have this permission, and then there's like forks in there, and we had it all laid out. And then once we started poking around in production, you start hitting all these weird edge cases you don't realize right away. So maybe we did something in December of 2010 where some repositories got created slightly differently than what you thought. And that's the part where what's really important is that your code should, when you push changes to production, you can't change production behavior. And that's a breaking change. So even though your tests can be totally green, they can be the best in the world, if you change production behavior, that's what breaks, and that's what's frustrating. So one way we tackle this is just to use something that's basically parallel code paths. So in the web world, say you have a request coming in, and you run your old code as usual. This always happens. But at the same time, either you fork it off or just right afterwards, you also run the new code that you're working on that you think is better or more appropriate for the future, something else. And then the trick is that you only return the response from that first old code. So from the user's perspective, they have no way of seeing anything new. Nothing will change on them. Nothing will break on them. They only see what happens in the old code, but you're also running the new code. The benefit there is that you get to run both, and then you compare the two results. So we wrote a library in Ruby that helps us out with this called Science, because this is basically, think back to science in high school or grade school or whatever you had it, or even today if you're lucky enough to be an actual scientist. But you think back and you have a control group and then you have an experimental group. And that's basically what this library helps us out with. So we have simple code like this. So you start out by saying, I have a control group, which is, in this case, let's use like a slow authorization code or authentication code to try and log somebody in. This is the stuff that always runs every single time, no matter what. And then we also have a candidate that we're testing out. I think this is going to be faster, or I think this is going to be more accurate, or I think this is going to be better for us to run. But I'm not totally sure yet. The cool part, we can run this as a percentage as well. So a lot of the times we'll roll it out to 1% of our users. So if it does have some weird impact performance-wise, we can scale it back down, turn it off, do whatever we want, or just run it at 100%. Then we wrap the whole thing up in an appropriately named science block, give it a name, and then this handles all of the collection of the two results. And there's a lot of really cool stuff that we can do from just this little bit of data. We tend to graph everything. So we use Graphite for literally pretty much everything on the site. And we can generate really cool graphs that help us out on this. So in this case, the blue graph up on top is all of the attempts that we tried to do when we ran this code. The red is the mismatches. So at the beginning, you can see, we had some problems in this particular case. Maybe we were just off, or they were returning different results from the new code and the old code. And then as you start iterating on it and you start fixing things and seeing edge cases, that red line would go down to the very bottom, and there's only a couple of blips. And that's interesting. And now at this point in this graph, you can look at the bottom and see very specific instances and say, okay, in I is 2, it blows up and it has a wrong result, and you can go back and fix that. So attempts versus mismatches was really helpful, but we also have a bunch of performance data as well. So in this case, we're looking at 75th and 99th percentile and looking at the performance between the new and the old code. A lot of the times what happens when you're pushing out new code, the average response time may go down, which is great, but if you don't look at these, the slowest end of requests that you look at, you may end up missing a lot of this. So in this case, like the green and the blue is our new code in the very slowest of requests, and it turns out it's a lot slower in that case. So maybe it's faster for the base case, and maybe that's good, but maybe not be better for the entire user base overall. So it's nice to have that data to actually split it up and get some new knowledge from this rather than just throwing it out to the wind and deploying it like crazy. And that's really what it's about, quickly iterating until you can prove safety. A lot of these cases, we'll leave it out in production for like a month or two as we tweak the knobs and try and figure out how do we match production, how do we not break stuff. And then once we deploy this, it's very safe. I mean, we can just deploy it and we don't really have to care because we have all this data that backs up what we're saying. And we know that this isn't going to break stuff. So that's really cool. Something else I've been thinking about a lot recently is existing process. And I think building into it is really interesting. In other words, what do you have today that you can already use rather than adding more? I was thinking about if you're adding more and more layers of process to actually getting code deployed, for example. Even though each step of these might be really easy, like I have to talk to my manager, then I have to talk to the release managers, then I have to talk to QA and ops. All of those steps may not be easy on the individual level, but taken as a whole, it's just a lot of cognitive load to try and tell a new hire, for example, okay, now you have to do these 20 steps in order to get your code in production. So I think it's really interesting to instead grow your process laterally. So you have a very simple process, but they're just more all-encompassing, if that's possible. Again, testing is really important for us, not a surprise. And we've been more and more putting more stuff into CI. Code maintenance is a really, it's kind of been new for us, and we've been doing more and more kind of maintenance tests and putting them in CI, and that's been really interesting. Usually we'd have people that would review our code in pull requests and then look for this sort of stuff, but if we can just automate that, it saves everyone a lot of time and it's a lot easier for us from a process perspective. So we've had a bunch of tests that have come out of this, just kind of naturally. So if you commit a piece of code that you remove the class attribute in HTML and you don't actually remove that in the corresponding CSS file, that won't break anything. It's not going to destroy the world, but it's like a cleanliness issue. You have more selectors, you have to have more stuff in your CSS files. We'd rather have that taken out. So why don't we just make it a failing test, which is what we do. Same thing for the reverse, removing the CSS without removing a corresponding HTML class in the views. We also have failing tests for if you add an image tag that's not on our CDN. from a security perspective, performance perspective. That's something that we want every time. Again, it's not going to break anything, but it's something that we want, so make it a failing test. We also run everything through SCSS's linting stuff, so make sure that your CSS is valid, even though, again, it may not break anything. This basically just automates the grunt work out of code review. As much as possible, if you can take somebody's job and make them focus on the stuff that actually matters and then automate all the other junk out of the way, that's good. This ended up being so awesome that we ended up doing the same thing for blog posts too. If you ship a new feature on GitHub, as part of the process of shipping your new feature, you get to write the blog post. So we have everyone sort of writing their own blog post, kind of as a toot your own horn type of deal. But these are all written by a lot, like sometimes dozens of different people internally at GitHub. And they're also in a repository, as most things are that we do at GitHub. And it turns out you can just run CI on, written word as well. So the same thing is like if you link to an image that's on our CDN, failing test. If it's the wrong dimensions, if it doesn't look good on like Retina screens, or if it's too big, if you put like a 10 megabyte animated GIF on it, that should be a failing test. Also, we do stuff like if you use an often used phrase. For some reason, we started doing blog posts with today we're introducing, today we're launching, and it was, it just got on our nerves for some reason. So that's a failing test. Now we don't have to be that asshole who says, just don't start your words with this. We can just say, test is broken, sorry, fix it. It's a lot easier. So that's really kind of interesting to think about, I think. I want to jump into the process next, though. Process is important, obviously, but the main question is what is important? And I think that results in a lot of really interesting parts about process. When you think about building something, a feature launch requires a lot of different people, from like developers, designers, but also, lawyers. Did I do anything illegal if I ship this? Marketing. Am I doing this in our branding styles? That's good. Ops. Am I going to burn down the data center if I deploy this? So you end up having, as your company grows, more and more chefs in the kitchen that all have to have a say in all of this sort of stuff. Part of, I think Ian was talking about earlier, is having simplicity and hiding all this complexity behind simplicity. And I think part of this that's interesting for me is just simple text files. You can have all of the amazing tools in the world, and sometimes the simplest is the best policy. For example, Apple does this a bunch. If you guys have ever read up on the ANNP, the Apple New Product Process, there's been a couple blog posts about it, and there's a book that detailed this as well. It's really interesting. It's basically a giant-ass checklist. As sophisticated as they make tools and as much money as they have, it comes down to just a simple checklist. And this is at the way high up on the Tim Cook level across the entire business, and it's also on the very small team level. I was talking to my friend at Apple, and she's like, yeah, we use checklists for everything. It just helps us keep on pace, and there's no ambiguity there. You can just look at the list. The interesting thing for me, looking at Apple, is that they do this as the very first step, or sometimes before the first step. So if you're going to launch a new product like a anklet, it's like an Apple Watch, but it's for your ankle. Say you're going to do that. As your very first step, you start a checklist and saying, well, how do we even start? Do we need access to the right internal dev servers? Do we have to have the right people? Are we looping in the right teams? And that's just a checklist. I think that's really interesting. At GitHub, we do something similar. We call them ship lists. And this, for us, tends to be at the very last part of the step. In the last couple of weeks, you're like, all right, I need to get this out the door. What do I need to do? And this is just a good way for us to loop in every single team and be like, would you be cool with me launching this here? Would I break any laws? Would I burn down the servers? Everyone's cool with this? Cool, and then I'll ship it. It's a very nice way to bring everyone on board without making it very heavy. NASA does this a bunch. Every single time you've looked at a really corny space movie and they say left thruster to on, check, all that sort of stuff. They're never like left thruster to on. Should I go 60% this time? I'm not actually sure. Should I I'm gonna rewire the back of this. The point of a checklist is that once you get to that point, you don't have to think. It's just done for you. All of the hard discussion and thoughts about it have already been done. There's a reason why they do this. Surgeons do this too, so you don't end up with scalpels stuck inside your liver before they sew you up. It turns out it's a good thing. Simple to-do lists make you think less. I think that's interesting, and we'll probably do checklists a lot more at GitHub. I think that's a really fun thing and lightweight way to handle process. Ownership is also really interesting to me. Basically what it comes down to is don't throw code over the wall. We tend to say, we tend to value responsibility highly when it comes to your code at GitHub. By that I mean, you deploy your own code. There's no other team that you say, all right, deploy my code. I'm going to go out and have a beer. It's on you if you break something to actually fix it. And there's a lot of implications surrounding that. So at GitHub, we try to tie code as much as possible straight to the writers of that code. For example, we'll notify you if you screw up. For example, maybe I deployed earlier today, which I did. Hubot will come in and say, well, we've seen a whole bunch of errors happen, and the last one to deploy was you, so that pings me. And I can go in and check out, I can look at all the errors and say like, all right, is this my fault? Is this somebody else I should talk to have them fix it with me? It's a nice way of just making sure that people are honest. Turns out people who write the code tend to know the best way how to fix the code. And I think the people who wrote the code should fix their bugs. This is the main problem I have with people who have, QA teams are fine if they're doing more testing and that side of thing is all fine. You just don't want to have a team that just has to deal with the crap. Because it's also terrible for them too, because they have to deal with all of the stuff that you just didn't want to bother to do. So ask yourself, how can your process help out? There's another really good example of this is Chrome, specifically Chromium, the open source project of Chrome. They have something that's called owner files, which are, as you'd expect, just plain flat files that just say who owns this piece of code. And that piece of code can be a couple of files or all the way up into larger modules of the Chrome code base. Again, all the tools in the world, and the simplest ends up being a really powerful tool. For one, this means it dictates responsibility. So if your name has managed to go into an owner's file, that's kind of like you're coming at it from like, I want to defend my position. I don't want somebody to commit code that's going to make my life worse. So I want you to have the responsibility and take the steps to make sure that the code that goes back into your branch is good. I think more importantly, it makes mentors very visible. So if you're really interested in getting involved into contributing to Chromium, it can be really frightening. There's so much code, there's so many people, there's so much happening at the same time. And it's hard, but if there's a very clear, I want to work on this piece of UI, oh, let me look in the owner's file, these are the 3 or 4 people that I can email and ask them for help. And that gets more people involved in your project. And that's pretty clear that's an open source thing, but it works just as well in your private company as well. If I want somebody else to help me out on this project, I want to make it easy for them to ask me for my advice if I can help them out with it. Back at GitHub, we do a similar thing, but we do more like on the per file level of ownership. So we use Ruby. So in this case, we're looking at a controller. At the top, we just write a quick method that says areas of responsibility, and then we pass it in a team. In this case, it's a GitHub team. So we have a team called Git, which handles all the low-level Git systems level stuff. And this means that for this file, they are responsible. When I do create errors, this is our internal error tracker called Haystack. As you can see at the end on the right, something is breaking. I can go up to the top, and then I look at who is responsible for this, and this is all pulled from the area of responsibility in the files that are touched by the stack trace that are in the error message. I can see who's in charge of this. I can click through to that, and then ultimately I can create an issue straight from that page and ping those teams directly. Again, even though I may have written that code a month ago, a year ago, I want to still have myself be in charge of fixing that. I don't want to just have somebody else do it because it creates a bad culture. So cool. The last little bit is talking about stuff, discussing stuff. If I want to sum up a lot, I do these talks a whole bunch, and usually can be summed up by more communication, like more emails, more notifications, use online chat a bunch, IM people. Awesome. I think that makes for a more transparent company. I think it makes for just better product. The problem is then you have a lot of communication, which can be problematic. I mean, issues, meetings, video, on call, like everybody wants your attention, and since somebody can ask you about it, you feel like you have to go in and talk about it. So it pulls you away from actually doing real work. So I think more communication is better, but I think better communication is even better. As part of that, I think most things aren't emergencies. And I think in the tech world, I mean, there's some things that are emergencies, don't get me wrong. If the servers are burning down, get a fire extinguisher. But there's a lot of cases where you feel like, I'm kind of blocked by this. You know, I should just like ping them. You know, they're maybe out of the office right now. You know, call them up, IM them, text message them or something. I think the first thing you have to do is just be mindful of people's time. Like, it's not always the case where you have to pull somebody away. And that's even the case, like, even if they are working, even if they are at the office. Pulling them away, you know, everybody knows the zone when they're really hacking on stuff and you're feeling really good. Getting pulled away from that sucks. So being mindful of your time is what we want. Like, how do we get there? I think part of that involves measuring the impact of your actions. I stole this example from my coworker. We were talking about this at dinner, and I loved it so much I wanted to add it in. Imagine this scenario. You know, you page your coworker for help. Either you text message them, or mention them in chat, or something like that. You're like, I need help with this. Maybe they are across the world and they get woken up, and then they're looking at it on their phone, and then their phone automatically takes a selfie of them and then drops it straight into chat. Like, what if that happened? What happens if you tried to talk to somebody and they look like that at you? Like, would that make you respect your coworker's time more? Like, we don't do this, but I think it's an awesome idea. I think that'd be interesting, because all of a sudden you start realizing that, like, oh man, I'm waking somebody up, or I'm pulling them away from something they were really deep into. It's kind of interesting to think about. Can you build tools inside your company that makes you rethink, just give me what I want, give me what I want. Add empathy to your process. And I think the real important part about this is that empathy stems from being exposed to real pain. In the case of the selfies thing, I can see somebody's morning breath and realize, okay, I've disturbed them from their slumber. But this can mean a lot of other things too. You hear this a lot, like everyone should do support. Everyone should support their products, support their code, and I think that ties right into the idea of responsibility, being responsible for your code. And that's great. As much as I love our support team, and I think it's great to have people specialized in that, I think it's also just as helpful to have people at least do a little bit a week, a little bit every month even. Because there's a difference between reading about it and helping with it. The number of times where some support team would be like, all right, we had 10 people complain about this feature you wrote, and then I'd reply back, okay, yeah, just tell them this workaround. That's different from if I actually handled their support thread and I actually had to go through, all right, the workaround is like these 6 steps. Oh man, that's a lot of work. I'm kind of a jerk for having you do all this. Like, can I figure out ways to rework this to make your life better? And I think that's really helpful. It's very easy to be inundated by communication externally from your users. It's also very easy to insulate yourself from your users as well. So get into that habit as well. Institutional teaching is kind of an interesting point too. I'm reading this book called Creativity Inc. By Ed Catmull, who co-founded Pixar, and he had this section that said, we have a responsibility to be teachers, that this should be a central part of our jobs. It's just logic that someday we won't be here. That's true in a lot of levels. We're all gonna die. I don't know if you noticed this yet, but probably not gonna beat the Reaper. So maybe we'll die at work, and heaven forbid, like, your work's not done before you die. That would suck. But other cases as well. Obviously, people leave companies, they build their own companies, they leave the industry, they do other stuff. So you want your knowledge to be transferred to other workers. It's also the case if you're in the company and you love the company and you just get a little bit burnt out on your team. You get a little burnt out on what you're doing, so you transfer yourself in your own company to somewhere else. All of this leads back to the idea that it's good to teach other people other things. Someday we won't be here, /dead. More productive, you're more productive if your workers are smart. That goes without saying. It's not mind-blowing. The trick is, like, how do you teach without making it really lame? Like, I'll give you a secret. Part of the reason I'm working is that I don't have to go to school anymore. School is lame. Some people really hated school with me. So I don't want to make this like some big thing where it's like, come over here, let me hammer this information into your head, because that's just not that super interesting. So can you make it just as a byproduct of how you're working, this sort of teaching, mentor-mentee relationship? Jesse Newland, who heads our ops team at GitHub, is fun. Either he made up the name ChatOps or he's talked about it a bunch. You should check out his talks if you're interested in this. But it's basically a way to learn by osmosis. We tend to do everything in chat at GitHub, partially because we're very remote, but partially I think it's just a better way to work. So for example, say the app crashes. A normal workflow would be, your employee gets paged again, server's down, and then they SSH into something, and then they fix it somehow. And if you ask them, they're like, oh yeah, I SSH'd in and I fixed it. And you're like, okay, what did you do? And even what they say may not actually give you enough information as what they actually did, if that makes sense. Having no invisibility means you're not actually teaching anybody. And having no invisibility also means no improvement. Like, how many times have you sat down with somebody you've never pair programmed with before, and they immediately do something that blows your mind? And you're like, I usually spend half an hour doing this, and you did it in 2 key combinations. That's because you have that visibility, and that's awesome. There's no reason you can't make your actual job the same sort of way. So we're a very distributed company. We do everything in chat. And a lot of this requires upon deep integration with your tools. We use Hubot, which is our chat room robot. Obviously, Amazon's APIs, PagerDuty to hook into all of our pages and stuff. We can trigger pages from chat. Obviously, we use GitHub a bunch too. So our workflow is something like this. An employee gets paged. They manage it all from a chat room. They can ask Hubot, which servers are online, which servers are full, is there a disk space issue? Show me a graph of the current connections to that server. Just show me as much as you can. And then they can fix it, and then people can watch. And a lot of the times you can do it straight from Hubot. Like, we can move repositories around disk. We can redo things on servers, all from just a bunch of shell scripts, basically. This means you can teach people. The number of times where I've gone to the ops room, because I'm not an ops guy, and I've just sat there and I've watched them handle some problem. Even though that's not my job, I've learned so much just from seeing them, which graphs they use, what type of response they'll do in the event of X going down. It's really interesting. And again, it means improvement. A number of times we'll have something where, if this server keeps going down every day, they'll run like 3 graphs and we're like, well, can we just wrap this all up into one command and then we're done? Just a couple of days ago, some repository was taking down a file server. And I was trying to figure out, how does this all work? And it turned out we had a Hubot command for that. And it would disable the repo, send an email, do all this sort of stuff, so I didn't have to think about it. We have improved the process and makes it a lot easier. The other really cool thing is real-life debugging. Right now, GitHub's Wi-Fi in our office is down on floor 2, which is a bummer because I'm going to go home, and that's usually where I end up hacking, which is terrible. But this is all being handled transparently in issues. So Jesse noticed this. He looked at our routers, like, yeah, the first bits of the office are all online. The second bits are down. Here's a trace route. Oh, I don't really know what's going on, but I'm still going to paste this in. Here's the heat map of the Wi-Fi in the office. That looks like a dead zone. Maybe we should fix it. And he goes into the cabinets and stuff, and he's like, this is the actual switch I'm looking at. I'm pretty sure this is the problem. And then at this point, everyone else in the thread starts going, okay, I have a replacement on the way. Can we fix this in the meantime? It's kind of interesting. Otherwise he would have, kept this all to himself and just would have gone in the hole and been like, yeah, I'll fix the internet in a day to 6 weeks or something. And we have no idea about any of this sort of stuff. So this sort of transparency can happen in a chat room, in issues, even in a meeting if you're all together and you're just doing this all together. I think this is a really powerful thing. And then you don't end up with these silos of people all, learning this knowledge that nobody else knows. The last thing I want to talk about today was feedback. Feedback, I think, is important, and I want to talk about the Blue Angels. I don't know if this is very American, but we have a fighter jet squadron that does really crazy. I found out they do 6 jets with 18 inches in between them, which is like 60 meters or something. I don't know your conversions or something. But they're really close together, and they're flying around, and it's nuts. And I saw this video earlier in the year, and it's fascinating. They're talking about feedback. After a show is done, how it all works together. I promise it's only 30 seconds, so it's interesting. If I have video.
Critical debriefing process, which they consider as important as the actual flight itself. They hash out what worked, what didn't, and no punches are pulled.
we are wide open as we can possibly be to criticisms, and we want to become our own worst critics.
We debrief everything. I'll tell you how specific it gets. We even debrief the march to our airplanes and the march back. So, and you get picked on for every little thing. And most of us haven't marched in 10 years of being in the Navy, so they get very, very specific.
The debriefing process takes probably twice as long as the flight took itself. Rank doesn't come into play, experience levels. Those are good, but you have to set those aside when the criticism starts to come, because that's the only way you're going to learn to maneuver, and that's the only way you're going to get to where the maneuver looks good and it's safe.
So they're crazy. Like, I think you have to be in the military to be this fine with, yeah, people just criticize all my stuff, it'll be fine, it won't stress me out. So I'm not saying act like the Blue Angels, because they're like robots or something. But I think it's an interesting thing. A number of things in there. Like, their feedback, their retrospective, like, is twice the length of the actual show. I think that's really interesting. They care about feedback that much. And the experience thing was really interesting too. Like, you can talk shit to your superior as much as possible. I don't know how much that is true, or that's what they're just saying. It's a cool idea, at least. Feedback is a two-way street. And the first part is, how well do you receive feedback? And I continually have to try and fix this for myself, because it's kind of human nature where you work on something for 2 or 3 hours and you're kind of happy with it, and then somebody comes in 5 minutes and says, man, this is not good, or this is terrible, or you are a terrible human being for writing this. Any number of which is possible, especially if you're in open source. And that sucks. Like, it's hard to just say, yeah, I'm divorced from my code. Give me that that's great feedback. I love it. So we have to do a better job at that. But a huge part of that is, how do you give feedback? And this is something that you really need to, I think, codify in your organization and try and figure out, well, what is good feedback? What works for our organization? What is that a matter of, the shit sandwich where you give them something really nice first and then you give them the really hard criticism afterwards, after you've sort of toned them down? Or do you want to be really straight to the point, no emotion? I think it kind of differs depending on people, but it's worth considering, like, how do we actually give better feedback? Because all of this plays into the whole process of improving your company, doing better code, delivering better product. So improving feedback across an org is a really important part. So be like the Blue Angels, be a robot, is what I'm saying. So overall, yeah, I think there's something to be said for moving fast with a degree of caution. I side along the side of breaking things. I like to move really fast and do crazy stuff. So when I say this, I say it with the knowledge of, man, this is actually, there's some pretty easy ways to get some good wins in making your code safer and do some really cool stuff fast. Because I think you do need to be fast. I'd rather work at a company that is fast than slow. Slow is death. You don't want to be in a dead company. And as your company ages, you want to be safe as well. You don't want to just throw away your customers' data. I almost made like 3 different jokes there that would upset lots of companies. So don't do that. And it takes effort to achieve both. I mean, it's easier to move fast and break things, but I think it's very possible to move just as fast and not break things as well. So that's what I've got. Thanks.